this is a video to show how convergence and probability implies convergence in distribution. So I have the definitions for convergence and probability and what I mean by that listed, and similarly for what I mean by convergence in distribution. For this proof, we're going to let all epsilon be greater than 0. Pretty standard. Then we have the CDF of x of n of x, which is equal to the probability xn is less than some little x. Again, this is just the definition of what a CDF is. Now, this can be written as the probability x of n less than little x and the absolute value of x of n minus x, absolute value less than or equal to epsilon. I'm going to do little parentheses, or x of n less than or equal to little x and absolute value of x of n minus x greater than epsilon in parentheses. This is less than or equal to the probability that x of n less than or equal to x. And instead of this little and or this like a cap symbol, I'm going to do a comma. X of n minus x less than or equal to epsilon plus the probability x of n less than or equal to x, comma, x of n minus x greater than epsilon. I'm going to refer to the left-hand side of this probability as A, and the right-hand side of, expression as B. So for A is equal to the probability x of n less than or equal to x minus epsilon less than or equal to x of n minus x less than or equal to epsilon, which is equal to the probability x of n less than or equal to x minus xn minus epsilon less than or equal to minus x less than or equal to epsilon minus xn. We can multiply 1 to every side of this inequality, which gives us x of n less than or equal to x, xn plus epsilon greater than or equal to x, greater than or equal to xn minus epsilon. Now, looking at here, we can combine these two terms. So x of n could be at maximum little x, and it can be anything below. So the upper bound for this inequality becomes little x plus epsilon. The lower bound, actually, there is no lower bound, it just goes to negative infinity because x of n could be anything strictly less than x. So we have little x plus epsilon less than or equal to x, which is equal to x less than or equal to little x plus epsilon, which is, well, I'll leave it there for now. Well, yeah. So then I have part B. The expression in B is actually going to be strictly or less than or equal to the probability that xn minus x greater than epsilon. And we see that pretty clearly. B has these two conditions. So the probability of A and B happening, so like of this expression and the second expression happening, is going to be less than or equal to just one of these events happening. So that's why we have B less than probability of the absolute value of x minus x being greater than epsilon. So what does this imply? This implies that f of xn of x is less than or equal to the probability that x is less than x plus epsilon, which is the A term, which is plus the B term, probability xn minus x greater than epsilon. So this is the B term, which implies that the limit supremum as n goes to infinity, f of xn, little x is less than or equal to f of x plus x, little x plus epsilon. If we take the limit of both sides of this expression, this one goes to 0 because we assumed xn minus x converges in probability, and then this becomes the CDF of x. So we can do a very similar idea to find the limit infimum. So changing colors for the limit infimum, we have the probability xn greater than little x is equal to the probability xn greater than little x, which is and xn minus x less than epsilon plus probability xn greater than x, xn minus x greater than equal to epsilon. Now I'm going to denote this term as A and the second term as B. So I'm just using a really similar idea as what we did before to find the limit infimum. Then we get A is equal to the probability xn greater than x minus epsilon less than xn minus x less than epsilon, which is equal to the probability. And I'm going to go ahead and skip to the end because this is actually really similar to what we did before. We're going to get x greater than little x minus epsilon. In B, again, a similar idea as what we did before. I'm going to have B is actually less than or equal to the probability of the absolute difference of xn and x greater than epsilon. I should say this is less than or equal to, and this one is strictly greater. That's better. So then we get that f of xn of little x is greater than or equal to f of x minus epsilon. Which implies that if we were to take the limit of both sides, we have the lim inf n to infinity f of xn x greater than or equal to f of little x plus e for x, which gives us f of x little x plus e. Sorry, this should be a minus e. Less than or equal to the lim inf less than or equal to the lim sup less than or equal to f of x plus epsilon. All of this implies that x of n converges in distribution to x by the squeeze theorem.